Today we're going to talk about polynomial functions and the leading coefficient test. So first, what is a polynomial function? Now we've been working with quadratics, where this is polynomial form. Now here we have where a, b, and c are constants. And notice how our exponents decrease by 1. We've got x squared and then x to the first, and here we really have an x to the 0. Now this is a quadratic. We have also come across a few cubic functions. So same form, we have our coefficients a, b, c, and d. And notice how our exponents decrease by 1. So we've got 3, then 2, then 1, then 0. Now this highest exponent here, the 2 and the 3, those are actually called the degree of the function. So for this quadratic, we would call this a second degree function, and our cubic is called a third degree function. And now we can have 4th degree functions or 15th degree functions or 72 degree functions. We can go really as high as we choose. So what I'm going to do now is write out the general form of a polynomial. Where that's our first term, some coefficient, where n is the degree. Then we'll have another coefficient. And this term will have an exponent that's 1 less than the degree. And then another coefficient. And a term that's 2 less than the degree. And that's going to keep on going until we get down to x squared, x to the first, and then our constant. So what we want to remember here is that all of our a's are constant, and n, which is the degree, must be a natural number. So that means that n can't be 0 or negative, or a fraction, and could be 1 or 2 or 3 or so on. So now for the leading coefficient test. This test helps us determine what the graph of a polynomial function might look like. So here I've got a bunch of different polynomial functions. So this guy out here, we know this one well. That's y equals x squared. That one's y equals x to the 4th. This green guy in here is y equals x to the 6th. And then the purple is y equals x to the 8th. And what you're going to notice is that all of these have an even degree, 2, 4, 6, and 8. And even degreed polynomials have the same basic shape here, where you see on the left side and the right side our function is rising. So left and right, our function rises. And now we'll change this a little bit, and we see that here we've got the reflection of all these functions. So this is negative x squared, and then we've got negative x to the 4th, negative x to the 6th, and so on. And we know from what we learned about transformations is that when we negate our function, that we end up with a reflection over the y, or over the x-axis. So now what we have are these functions that are falling to the left and to the right. So now we're taking a look at even degreed functions. This guy here is y equals x cubed. The blue is x to the 5th, the green is x to the 7th, and the purple is x to the 9th. Notice that when we have an odd degree, that our function is rising to the right and falling to the left. And last group here, we've got the reflections. So again, when we negate a function, we know that we're reflecting the graph over the x-axis. So this is negative x cubed, y equals negative x to the 5th, and so on. And we see that when we've got an odd degree and a negative leading coefficient, that we're falling to the right and rising to the left. So let's summarize that leading coefficient test. We've got 4 cases. The first case is if n is even, and our leading coefficient, which I'll call a, is positive. When that happens, we don't necessarily know what's going on kind of in the center, but we do know that our graph rises to the left and to the right. Second case is if n is even and our leading coefficient is negative. Again, we don't necessarily know what's going on in the center, but we do know that our graph is falling to the left and to the right. If n is odd and our leading coefficient is positive, we know that our graph rises to the right, falls to the left. And again, if n is odd and the leading coefficient is negative, we have the opposite where our graph rises to the left and falls to the right. So if we see a function that looks like this, we may not know exactly what the graph looks like, but we see that the leading coefficient is negative and that the degree is odd, which is this case. N is odd, the leading coefficient is negative, so we know that that graph has to rise on the left and fall on the right.